Hey everyone, so imagine you could take a couple grams of material, something that fits in the palm of your hand, and somehow it contains the same surface area as an entire football pitch. Sounds impossible, right? Well, three scientists just won the Nobel Prize in chemistry for making exactly that happen. And trust me, this isn't just some cool lab trick. We're talking about materials that could literally pull drinking water out of desert air, suck carbon dioxide straight from the atmosphere, and clean up those nasty forever chemicals that have been polluting our water. I'm talking about something called metal organic frameworks, or MOFs for short. Now, before your eyes glaze over at the sciencey name, think of them like this. Imagine building with Lego blocks, but instead of plastic bricks, you're using metal atoms as corner pieces and long organic molecules as the connecting rods. When you put these together just right, you get these incredible crystal structures that are basically full of holes. But holes with a purpose. It's like building a microscopic apartment complex where every room is designed to trap specific molecules. So who figured this out? Three brilliant minds. Susumu Kitagawa from Japan, Richard Robson from Australia, and Omar Yagi from the US. The story starts back in 1989 when Richard Robson had this wild idea. He looked at diamond crystals, those super strong gems, and thought, what if I could make something similar but with cavities? So he combined copper ions with a four-armed organic molecule, and boom, he created what he described as a diamond filled with innumerable cavities. But here's the thing. His first attempts were like building a house of cards in a windstorm. They looked amazing, but they collapsed if you looked at them wrong. That's where Kitagawa and Yagi came in. Between 1992 and 2003, these two scientists, working separately, figured out how to make these structures actually stable. Kitagawa discovered that gases could flow in and out of these frameworks, and he predicted they could be made flexible, basically breathing like tiny lungs. Meanwhile, Yagi created incredibly stable MOFs and showed that you could design them with precision, like having a molecular blueprint where you know exactly what you're building and why. Now, here's where it gets really exciting. Remember that football pitch surface area I mentioned? That's not an exaggeration. Some of these MOFs have so many internal nooks and crannies that 2 grams literally contains as much surface area as an entire football field. And what can you do with all that space? Well, Yagi's team has already built devices that harvest drinking water from the Arizona desert air. Picture this. It's nighttime in the desert. The MOF absorbs water vapor from the air. Then, when the sun comes up and heats it, boom, fresh drinking water drips out. It's like having a high-tech water well that works anywhere. But wait, there's more. Climate change getting you down? Some MLFs can capture carbon dioxide so efficiently that they're already being tested in industrial plants. Worried about those forever chemicals, PFAS, contaminating our water? Yep, there are MOFs for that too. Scientists have now created tens of thousands of different MOF structures. It's like having a molecular toolbox where each tool is perfectly designed for a specific job. Need to store hydrogen for clean energy? There's a MOF for that. Want to clean pharmaceutical residues from wastewater? There's a MOF for that too. Smart. Some of them literally change shape when they fill up with gas. They breathe in and out like living things. Others can grab onto specific molecules while completely ignoring everything else around them. This sounds too good to be true, right? And you're not wrong to be a bit skeptical. The big challenge now is scaling this up. Making a few grams in a lab is one thing, but producing tons of the stuff for industrial use? That's the next mountain to climb. We're not just talking about incremental improvements to existing technology. This is a completely new class of materials that didn't exist 35 years ago. And now they're being recognized with the highest honor in chemistry. In your lifetime, you might see buildings that literally breathe carbon dioxide out of the air, cars that run on hydrogen, stored in materials smaller than your smartphone, or communities in desert regions that generate their own drinking water just from the moisture in the air. And honestly, I think we're just getting started. What do you think? Could MOFs be the game changer we need for climate change and water scarcity? Drop your thoughts in the comments below. And if you found this as mind-blowing as I did, hit that like button and subscribe for more science that's actually changing the world.